In this video here, we are going to be talking about positive trig functions on a coordinate system. So most of us understand that when we have, our quadrants, the first quadrant here is going to be all positive values for x's and y's. And then second quadrant, the x values are negative, but the y values are positive. And the third quadrant's where everything's negative, x's and y's are negatives. And the fourth quadrant has the x being positive and the y being negative, since we're down here below the x-axis, so all the y values are negative. That being said, that affects our perception of our trig values. So let me just go into this. Basically, remember how we said that sine, let me write this out. So sine is associated to the y values, cosine is associated to the x values, and tangent is associated to the y and x value. And then the reciprocal, so cosecant is 1 over y, secant is 1 over x, and then tangent, sorry, not tangent, cotangent is x over y. So if these are trig identities for the coordinate system, well, that affects the signs if we are in certain quadrants. So what I mean here is that notice that the first quadrant, everything gets to be positive. The x is positive, the y is positive. So this is kind of nice. That means for any of the trig values, they'll always be positive. And so what we're going to do is identify what is the positive trig function for that given quadrant. So in the first one here, all of the trig functions can be positive here. So from sine to cotangent, anything here can be positive. Now for the second one here, it looks like the x here is a negative and the y is a positive. So anything that consumes a y is positive. And that is going to be a sine and cosecant. I want you to notice that when it comes to tangent and cotangent, yes, they do have a y value, but they also have an x value that they use. So if I were in the second quadrant and I threw in my x value, well, they're going to be negative. So then the overall answer or the overall fraction would end up being negative. So these two, sine and cosecant, are the only ones that have y's. So they will be the one that guarantees to be a positive trig function. So positive in the second quadrant is only sine and cosecant. Let's take a look down in the third quadrant here. So both of these are negative, so x and y's get to be negative here. Now, if x was negative, that means that the cosine and sine, or this cosine and secant, would be negative. So we don't want to use these as our positive. As for y being negative, that would affect sine and cosecant. So none of these are going to work out because they would produce negative answers since we're in the third quadrant. The only time that it gets to be positive if you consume both x and y. Notice how if tangent uses x and y, and you had a negative on top and negative on bottom, when you divide, they become a positive. Same thing for cotangent. There's an x and a y, so both of them would be negative in the third quadrant, so they would end up being a positive value. So in this case, the only thing that can be positive in the third quadrant is tangent and cotangent. All right, the fourth quadrant here, it looks like the x here is positive and the y here is the thing that's negative. So I already know sine and cosecant are out because those would end up being negative. And same thing, tangent and cotangent would be out because the y would be a negative, and so both of these have a y where the x is a positive. So this would overall be a negative answer. So the only winner here is cosine and secant. So those are my positive trig values. So it's going to be cosine and secant, the reciprocal. So that means first quadrant is any type of trig function is positive. The second quadrant is sine and cosecant. The third quadrant is tangent and cotangent. And the fourth quadrant, cosine and secant. So this chart here tells you what positive trig functions are on the coordinate. And you'll use this quite a bit for the next two problems. I also want to show you an acronym that we use. So you can see that the first one has all the trig function, the second one has sine specifically, and cosecant here is a reciprocal of sine. So we just really need to remember sine. So the first quadrant is going to be represented with an A for all, S for sine, T for tangent, because the reciprocal of tangent is cotangent, so we just need to remember tangent. And then the fourth quadrant here is going to be cosine, which starts with a C, and the reciprocal of cosine is secant. So that means that we can remember the quadrants by remembering A, S, T, C, or my favorite acronym, and feel free to use it, is all students take cash. So if you can remember all students take cash, notice the letters here, A for all, S for secant, T for tangent, C for cosine, you can remember this coordinate system. And we go in that order. So this is first, second, third, fourth. And this is an acronym we use to remember the trig functions that are positive for that specific quadrant. There's also another funny one out there that's all students take calculus, but I don't like that one as much. I think this one's funnier and easier to remember. All right, so going into example 5 here, it needs to determine the trig function that has a positive angle, which that is given in degrees. So here you're given a degree, and you have to figure out which angles would be positive here. So which out of these 6 trig identities would be positive. So in that case, for 74 degrees, let's just draw where 74 degrees would land. So if this is 90 degrees, this is 0, and this is 180, 74 would land somewhere in the first quadrant. So that's all I need to know. It's in the first quadrant. Well, the first quadrant says that any of the trig functions can be positive here. So I'm just going to write down here, all are positive. Because it's the first quadrant, all of the x and y values are positive there. So any of the trig functions can exist to be positive here. Whereas 218, if we were to draw the angle, so 180 is on this side, 360 is here, and 270 is down here. So that means that 218 is somewhere in the third quadrant. So in the third quadrant here, we have 218. So that means that this would be representing tangent. So the only thing that can be positive here is tangent and its reciprocal, cotangent. So I'm going to write that down. So tangent and cotangent are positive. Sorry for my scribbly handwriting. And then this one here is negative 15. So if I were to draw negative 15, remember we're going in the clockwise direction. So that would be this way. So if this starts at 0, this would be negative 90 degrees. But our angle is somewhere in the fourth quadrant because it's just negative 15. So that's a number between negative 90 and 0. So this is the fourth quadrant here. The fourth quadrant says that cosine is positive here. Notice how like the x values here, the cosine's positive, but the y values are negative. So that means sine's negative. So cosine's the only thing that works here that is positive, and it's reciprocal. So that means cosine works and secant would work. So they're the only things that are positive here. And that's it. So let's try another one where we have a few condition statements. So let's look at problem 6 or example 6. It says determine the signs of the trig functions that are positive angles within the degree. So let's zoom into our condition statement for a sec. So for me, I have to understand first that when I see these symbols here, greater than or less than, and it's being compared to 0, let's just, step back for a moment and understand what that means. So I'll put a little note here for us. So whenever something, let's say x instead of sine, is greater than 0, that means that it's saying that this number is positive. Anything that's bigger than 0 means that it's a positive number. So let's make a little note of that. Anytime it says greater than 0, it is a positive value. And then anytime it says x is less than 0, that means it is a negative value because these are numbers behind 0. And so now that we understand what these inequalities means, we can try to interpret what these trig statements are saying. So we're given these condition statements and we have to figure out which quadrant works for both of these statements. So it's like they tell us sine and cosines are positive or negative, and we have to figure out which quadrant would work. So in this case here, let's look at A. So A says that sine is greater than 0. So this is saying that sine is positive. So we have a positive sign, and this cosine here says positive as well because cosine is bigger than 0. Well, that being the case, we can try to interpret sine here. When sine is positive, let's draw our, I don't know about you, but I will need to draw my coordinate. So all students take calculus, or all students take cash. That's my favorite. So in this case, this means that the first quadrant is all the trig values. The second quadrant is sine and cosecant, the reciprocal. And the third quadrant is tangent and its reciprocal, which is cotangent. And then the fourth quadrant is going to be cosine, which its reciprocal is secant. Now that we have the coordinate system, let's go ahead and figure out where sine is positive. So sine is positive in the first quadrant and the second quadrant, and nowhere else. So I'm going to just write down those labels, so first and second. And I'm going to do the same for cosine. So cosine is positive also in the first quadrant, but cosine is positive in the fourth quadrant. And now what you're going to do is compare and see which one do they both have in common. It's kind of like playing Go Fish. It's like, do you have a quadrant 1? Yes, I do. And so in this case, both have a quadrant 1, but notice that the other quadrants, they don't match. So we're going to ignore those. So these are the quadrants that they have in common. So we're going to say that they're both, sine is both positive and cosine is positive when it is in the first quadrant. And so that there is my answer. So I'm looking for which quadrant satisfied both conditional statements. So this one here says secant needs to be positive. So secant is equivalent to cosine. So secant is positive in the first quadrant. Anything's positive in the first quadrant. And it's positive in the fourth quadrant. Tangent says that it's going to be negative. So we're looking for where is tangent negative. Well, and that's the case. Let's first figure out where tangent is positive and then ignore them. So tangent is positive in the first quadrant and in the third quadrant. So that means we don't want to choose these two, the first and the third. We want to choose the opposites so that way we can get the negative trig values. So we're going to pick the second quadrant and the fourth quadrant. And so if you were to match these, the only thing that matches is the fourth quadrant here. So that means that the fourth quadrant, oops, that's a highlighter. The fourth quadrant is our quadrant that satisfies both of these conditions. So just as a reminder here, for negative trig values, what you need to do is find the positive. So in this case, we found that tangent was positive in first and third. And then you want to not choose those that are positive. You want to choose the opposites that were negative. So that's why I chose the second and the fourth quadrant. All right, C here says cosecant is, this statement here says negative, since it's saying that it's less than. So where cosecant is positive is the first quadrant and the second quadrant. So the negatives would be the third and fourth. So I need to write down the third quadrant and the fourth quadrant. For secant, this is going to be, it says that secant is less than 0, so this is also a negative secant that I have here. So when secant is positive, is in the fourth quadrant and the first quadrant. So secant is positive in the first and fourth, but that means that quadrant 2 and 3 is where it is negative. So quadrant 2 and quadrant 3. And if we look, that means that the two common quadrants are going to be quadrant 3. So both of these have quadrant 3, so our common quadrant here is going to be quadrant 3. And that's it for this video. In the next video, I'll talk about reference angles.